Welcome to Data Frames and R programming language. Data frame is a data structure in R programming language. In this video, I'm going to discuss what a data frame is. Data frame basically is made up of rows and columns. It's like a table or the data structure that has record of vectors that could be characters, could be uppercase characters, could be logical values, or could be numbers, any kind of data type within these columns, but they have to be homogeneous when it is talking about the variable or the column name. And the rows are different record, as you can see here. So a vector v1 is between 5 to 9, and a character lowercase e to I is one column, and character uppercase R is also case sensitive. So when you're writing C1 is different than C1 with the C uppercase character. And C2 here, I define it as uppercase. So E through I is stored on character 2. Later on, I'm going to show you how to create these vectors and how to just assign them into a data frame using the data.frame function calls. Our basic language also already supports it. Our basic packages that are there already support the data frame as a data structure, vector as a data structure, array as a data structure, matrix, and factor, and then list, and all of that, right? So data frame is one of the data structure that we are going to be discussing today, which contains a number of vectors in this example, which are 4 columns. Columns, or each of one of these vectors are representing one column, and then one column has homogeneous data, as these are all logical, and this is all uppercase characters. These are all lowercase characters, and these are numbers. But then each record could be information that is stored into the table as a field, as a record, as a row, but containing those fields values. So sometimes these rows has to be on the database, relational database, because there's a lot of primary key, foreign key relationship. You just have to make these records unique. In our programming language, when you have a table or table, when you just are using them, you could make a distinct record or a unique record out of it. There's a package called dplyr. Dplyr is a data manipulation grammar of data manipulation language for R language. It has a lot of functions such as select, filters, and pull, and all of that other related packages that are defined, related functions that are defined within this dplyr data manipulation package that you can do this kind of work here. So on this video, I'm going to show you these 4 pans within R Studio, how you're going to use each pan, and how to define a vector, how to get their types, the structures, and the class, and all of that. I'll discuss all of that. And this one, since it is a source, as you can see, this code that I wrote from line 1 through whatever line number is, this is R script is the R interpreter. This shebang is saying that run this one from the command line. If you run this program on a Windows machine, you will say // on the directory of this, whatever is the name of this program is called dataframe.r. It will just load the interpreter, which is rscript.exec executable from this directory. Then it understands these syntax. And then if the syntax and semantic is working, then you get this kind of output as your data frame when you source it. So when you click on this source button here, basically it source this code, which is this file, as a R script saved as dataframe.r in this directory structure, and this is the output. So I'm showing you here. Also, if you just go on the help and just write the name of the package, You get a dplyr package, all the information, and you have the scroll bar that you can read up and down. These other environment variable, I will also explain it to you. But with this, let's just go to the second slide, which is a data frame or data structure. And I'm going to also demonstrate the dplyr package, data manipulation, some part of it, like maybe select a statement and maybe filter, whatever comes out as a result of the discussion, I'll explain those ones. In our programming language, those functions that are defined within dplyr, if it is not in the basic R package, then you have to load the dplyr package, and then some of the functions that are defined, like glimpse and summarize and select, filter, pull, all of those ones, you have to have these package. And I'll also explain that a scope resolution versus a regular load of the package name. So I'm going to be thanking you ahead of time for spending your time, and I appreciate your valuable time. I hope this video is going to help you understand how to do data manipulation using R language with the dplyr package. At the same time, what is a vector, what's a data frame, all of that. I'm going to demonstrate the lab activity. Please stay tuned, and now we will just go through R Studio to explain all of that. So first thing, let's get into R Studio. By clicking this R Studio, I have already have the program loaded to save your time, and then I've run it. I'm going to just clear my screen on this one. This pane that is there, if I just do Control L, it's going to clear the screen. And you can see if I say R dot system sys.r sys.version, let's say, if I want to get the version, sys dot, let me see if dot info is the one, and then you have to write it as a function, not with zero, sorry, typo. And then a system.information, you can see that all the, it's a Windows operating system, I'm doing that one. And then sys dot version is somewhere here also. You can type in exactly the word that it is there with the version, and then you will get the version information, or TUV. So if I just type in V here, let's see if it comes out. So get environment here, R dot version maybe, yeah, it's actually R dot version, not the sys dot version. So sometimes these statements are all over, so you just have to know where it is. R dot version will give you the version number that we're running here on the console. So at this time, I'm going to just clear my screen and run one of these lines. Each line of the code that I run, so I clear my screen first here on the console. I'm going to just run this statement. By doing that one, if I just say run here, it's gonna just say v1 5:9. All I did was here an assignment statement using assignment statement operator. I assign 5 through 9 to a vector 1, a v1. So now v1 is already having that value of this. In order to do this one, I could also uncomment this line, and then the pound is basically saying that commented out. So now if I run this one, basically it says print paste type of v1 is equal. This paste function is nested within the print function. So when you're writing a string with some variable, this is how R does it. You just put the string here that you want to print, type of v1 is equal, and then type of v1 is there, and then print the statement. It will do that one. But notice that here I'm going to get the type of v1, and then here it says type of v1 is integer. But if I just say, well, that's good, I just want to comment this one, I want to get a shorter version of this one, I could run type of here, and then it says the same integer that this output produced here that is there, right? So at the same time, if I uncomment this line here for more concatenation, kind of like more descriptive information with the print statement, that you say class of v1 is equal, and then you give the class of v1. You can do that one, and it will say the same thing as that one. So for now, I just put the comment back, and this is essentially the same. So I'm going to just run that one, and says is class of v1 is integer, because basically 5 through 9 are integer, right? So if I want to run it, I could just type in v1 here or print v1. So whichever syntax you want to use, that's fine. You could do that one. And right here, those print vector v1, again, if you want to just see the word like that, you could just do that one, and then give the print v1, and then print v1 like I did here, v1. So you could just get that. So now we're on line 13. We're done with the v1 vector. We're creating a new vector called letters, but not, sorry, the letters of, this is almost like a function calls. So this is a function between 5 to 9, whatever the letter is, E start maybe 5, and then on through 9, it will be lowercase characters. Since this is lowercase, this only generate a lowercase character and assign it to C1. So when I run this code and say run here, it's going to just run the entire code and say 1. Now if I'm here, let me just undo that statement here. So you can go undo here, and then the last statement, and then undo one more time because I deleted it. And then I can say file save, and it will save the last change there. So now I did the C1, and if I just say type of C1, run that one, you can see its character. The only difference between the other one was numbers, and this one is type of lowercase characters. So now if I say, give me the class of it, it is also going to say character. And then if I want to actually see the value of it, I could do it with print, but I commented out. I can also just do C1, it will print it. And you can see each character or there as unique. So like, let me undo that one again. I mistyped. When you're on the screen here, so let me see where I am, right here. C1, you can also print a character, like if I just say C1 sub 1, that one will just print E. C1 sub 2 would print the next character. Similarly, for the V1 sub 1 will print 5, and V1 sub 5 will print 9, and so on. So like if I want to see C1 sub 5, it's going to print I. If I want to say C1 1 to 5, then it's going to be printing all of them. If you don't do this one, automatically it's going to print everything that is there. Notice at this time, uppercase C2 does not exist. So if I do this one, C2 actually, I have already run the script, it's already there. The way you know your storage, you can do a list here, and you can see that all the storage that you have run it is defined already. So now if I go back to the C2 here, and then run this one, say, go ahead, run it, and just type of C2. Type of C2, if I do this one, type of C2, you can see its character. Class of C2 is also character, but value of C2 is uppercase letters, right? E through I. And then if I just want to say, for example, here, I say C2 sub 3, so this one is sub 1, this is sub 2, I am printing G. And then that's how you get into index of each of those letters itself. So if you wanted, like, for example, the 5, which is I, it will print I. And if you wanted 1 through 5, you can get all of it. That's indexing. And then same thing with logical values. Notice the logical values, I'm using this function called collect or collection or combine or concatenate. You can call it whatever, but it's a collection of logical values that are 5 of them. On all of these ones, as you can see, that the vectors that I defined, they're having same number of rows because it's important for a table to have the same kind of number of rows. Otherwise, the entry will have missing value for a given column. And null values are allowed, values that are not available at the time. Sometimes missing data is called null or not available or not accessible at this time. But later on, when you have it, for example, a car accident happens and the hit and run guy runs away, unfortunately, and then he's not honest, and then they don't have a record of who the hit and run driver was. But once they caught it, they put the information in the database, and the DMV record is populated with correct information. So, and when you're looking at this one, that's basically null or missing value is not that is empty. It is at that time it's unknown. The meaning that maybe at some point it's going to be declared with the value that are missing. So on a table, you could have all kind of fields with missing records or populated record, but their data types usually, or the fields and data types, the column values. So here we are doing a type of logical, and then if you just run this one, it says it's a logical type of this is going to say logical because true and false are logical, and then a class of them is also. And if you say L1 there, again, L1 of sub 5 is true, so that will just return true there. L1 of 4 is false, then it's going to return false. So if you just want all of them 1 through 5, then you can just do that one. Something that is not defined, you cannot access it. Like L sub 6 is not defined, and you can see it's not applicable or not available, those values. Usually it's out of index on other programming language, but this one is a little bit smart in terms of, like, if you're accessing a range that is out of the scope of that one, it says just that is not available. So I could say 6, 7, 8 or something, all of them are there. 1,000, it doesn't matter how many records are there, you just say that record is not there. That field has no value. And at the same time, I'm just going to create a data frame. Data frame is a function, and then it could take 1 or more fields. In this case, all those 4 fields are vectors of data. These vectors could have different type. Like you can see, V1 is an integer or number, C1 is character, lowercase, uppercase, C2 is a character in uppercase, and L1 is logical data type. These data types within each column has to be the same, but within each row, they have different data types. A row is made up of all these fields, and each field is a variable. So you can index these variables and data manipulation dplyr package, and some of the function like select, filter, and other ones, pull, all of those ones, you can get them by column names, which are actual name like V1, V2, or city name, country name, or animal, fruits, all those kind of names. Or you can do it by index, like this would be 1, this would be 2, this 3, and so on. So I'll later on show you the data frame when you have access to it. Let's just run this one, assign the df, the value of this vector, which is V1 as the first column, C1 as the second column, C2 as third column, and L1 as that. Now we have defined it. Let's say what type of data frame. It says it's a list. It's a list because each record is different data values. So a list could have multiple data types in it, but they can be homogeneous or heterogeneous. A list within a list could be defined, but a list is a data structure also itself, like Victor and other ones. And then this one, the class of it is going to say is a data frame. So what data structure it is a data frame data structure. And if I just want to print it also, obviously it will print me the value of the data frame. And then also if you do a df by itself without the print statement, that also does the data frame here. So at this time, we're using the R language, basic package manipulation. So we have not loaded any package or anything, but because I loaded the dplyr package already, I can just go here and then look for the dplyr package and then unload it, detach it. So you can do it from the command line also, or you could just go here and then find the package and say, let's just unload it first. I'm going to show you some of the scope resolution and other ones like I mentioned. dplyr, let me see, I think it is up here. Yeah, right here. You see this dplyr? So I'm going to move this thing a little bit here, and then I'm going to just say loaded. If it is not loaded here right now, if I want to just do like a data frame, some package like pull a statement and function, or glimpse or summarize, none of those packages functions that are defined on dplyr, it's not loaded here. So in order to load it, you can use the library command. Library name and dplyr is this, or use the require command, require function or library function, and then load it as library. But if you want to detach it, if it's already attached, you use the detach command function. So in the syntax, if you just click here, notice if I click on here, the actual code is going to run with the library. And notice that the library already ran here. And then this is how it is getting attached. If you didn't know this one, you knew the syntax, you could have just done library or dplyr. So now if I just, and it says what are the functions that are available here. Once you load this package, then a lot of the functions that are for data manipulation, this grammar of data manipulation with version 1.1.4 will be available for you. So if I detach it here, notice it says detach package colon dplyr. This is basically saying which package I want to detach it. And this unload is equal true, meaning that, yeah, you have to unload it for me. So when I do dplyr, notice I said either you type in library and dplyr, or you click there, it will be the same thing. Now it is just checked again. If I detach it, notice that detach command is there. If I just say detach it, and then it's going to do it. Now this time I'm going to do require. I told you that require in the library or similar to like Python import package, or C and C++ include, or require like Perl uses require. So in the computer science major, you're going to learn a lot of multiple languages, at least 5, 6, 7, 10, depending on what school you go to. And when you do the job industry, you have a lot of them, more than 10. So at the same time, you're going to memorize some of these syntax, but the nice thing is some of them are almost similar style, except they use a different word. And so that is that hard part of it, that you cannot keep track of thousands of packages in every programming languages and millions of function calls and this and that. So, but when you are doing like a data structure and then a concept of programming, top-down design or procedure programming, function programming, object-oriented programming, you're using a kind of a methodical way to just understand the system. So whether you do it on our language and you did not use the Python for a while, now you jump in on R or vice versa, it's much easy, believe me. If you learn it once, it's going to be like swimming. If you learn how to swim, you don't have to be on the pool every time. You just know how to swim when you, similar to driving, similar to playing soccer. Yes, you have to refresh it because if you want to do a corner kick and score it from the corner, you have to practice it constantly, similarly to these packages when you work with it. So let's go back to the dplyr. If you look at the dplyr here, I'm going to use the require, and the require somehow it just did not load it. It says, what do you mean the dplyr? Because I put an extra E, and that's not the name of the package. So dplyr, this one, it loads it, and now it's checked it. And then I'm gonna uncheck it. So now it is not loaded. Now I want to see if I just, since I unloaded it, I'm going to see if I can use the package name called glimpse. So I'm going to say, this is my data frame. I want to get a glimpse of this one, data frame. I'm going to say glimpse data frame. So notice it says, I don't understand what you mean by glimpse, because this package is defined on dplyr. Dplyr is not loaded. If the package is not loaded, you cannot use a function within that package. The only way you could use it is to say the name of the package first and colon. This colon in C++, we use for the standard IO, .h and IO stream .h and all cout, cn, all of those ones as scope resolution. A scope resolution in the concept of computer science is saying that where is this function glimpses defined is on the parent is the package name is dplyr. So you say this one, and if you tap here, all of the functions that are available within dplyr, it is available for you. And glimpse, as you can see here, is one of them. Glimpses here. So you can see, for example, if I say glimpse here, now glimpse has a function as the argument. So the argument, it says the data value, and I could have width or other parameters. And then the nice thing about IDE, it's going to help you with IntelliSense. It gives you some information. So in this case, all I need is give that data frame there, but I missed the E here. And then that would give you a very nice, it says it has a table in the form of rows and columns with 5 rows and 4 columns, and columns are V1 through L1, or the name of the fields or variables on this. So data frame $V1 would give me that one, which is the field one. And data frame $C1 will give me character 1. Data frame capital C2 will give me the C2. Data frame $logical 1 will give me the logical values. At the same time, if I want to get every one of them, you can get that data value. Notice that the syntax I use the glimpse here, I can use, say, pull some information, another function, pull, and then I just do this one. Now I get the value of data frame with pull, all that information from data frame that. But if I just say, give me V1, and then unexpected sample and dplyr pull, and there's comma. This is the data frame and then the field name. And then this C1 is the character, and then uppercase C2 is those, and then logical 1 is there. So notice that I'm using the pull. And if you have the question on how to use poll. If I do this one, it says that, okay, to use poll on dplyr, this is how the function is, data frame, and then all the variables and all those values that you can do. And they give you some examples you can play around. But at the same time, if you say glimpse as a function called give me that, and it gives you a lot of details here, you can just look at it, whichever one you're interested in, and then click on it, and then regular expression with tables and so on. But just the glimpse itself, you could do glimpse in here, and then click on this one, and then maybe this one is going to give you like empty course glimpse of that. So these are data sets there, and this is a filter that you could get that information. From time to time, I'm going to do a lot more demo on that one. So since I'm not using this side of the screen as much, I'm going to move this one here. And then at this time, we already did all of that. I'm going to move this one also up here. Or I could just click on this one and then maximize it and then have it all the way here. You have only one screen here that you could see everything here. So, but I want you to understand the concept first. So let's say here I did actually, let me just put this one back because I want you to see the package here. The dplyr, and that was already right here, was checked. Notice that I was doing with the glimpse and other ones through the package, right? So if I just do it without the package name, without the scope resolution, because I haven't loaded the dplyr package, it's not gonna read it. It says, I don't understand the pull function. But if I wanna get the pull function or select function or other ones, then I need to load that package. So in order to do that one, I'm gonna say dplyr. Now it is loaded. Now this dplyr is checked here. You can see that if I just do up arrow here and say pull df, it's going to give me the data. I'm do the same thing, C1, it's going to give me the data. C2 is there. Notice that sometimes C2 is not defined, so C2 was uppercase C. It's case sensitive, so if you just do it with lowercase c and lowercase c2 was not there. Remember that I said that these are the functions that were already defined here. So I'm going to also show you a trick that you could use for these storage to clear your storage while we are in there. Maybe another session, but at this time we're ready already to show you that. So let me just do that one for a demo purpose. You might be saying that, how could I clear my storage variables? So if I just do Control L here and say ls, this is list of all the variables. C1 is there, C2 is there, and all the other ones, right? Logical 1 is there, and then V1 is there. So if I want to just delete one of them, like remove a C1, I could do that, remove C1. Now, if I do ls, notice that it is only other ones are there. At the same time, if I want to delete RM uppercase C2, you can do a remove or RM as a kind of a short version. It will do the same thing. Now notice that they are there. But if you wanted to delete all three of them now in one shot, rather than just do it one by one, you could just do a nested function call. So remove is the function, and then you say list is equal, and then give the ls command as the output of that one. Now all of them are gone. And you can see that ls is nothing. So here I did the remove function similar to that one, but I generated a list out of the output of this ls command. And then I assigned it to list, and then now df becomes an argument to rm, remove a command L1 and V1, and it is now 0. There's nothing here. But notice that I could easily generate it, the same list here, if I just move this one back to a smaller screen. Let me just clear this screen here. Control L, and then you can see ls, there's nothing here, right? So what we could do is this source code that is there, remember I was showing you one line at a time that you want to do. If you want to source your code, file is saved on a directory and that I saved it. So let me just go on the Windows command prompt or file manager. You could use File Explorer here, and then just go to the directory where I have the program, which is this PC, C drive, and then demo, programs, and then R language, and then this is the dataframe.r, this one. So notice that when I run that program, it opens in Visual Studio Code. I can even compile it here. This was the actual code here. So if I just run it, I just get the output right here like other ones. I'm going to just demonstrate here. I could also open and say open with, and then open it in the Notepad or Studio or some other language. So I could open it with the edited Notepad. You could see the code here. This is the actual code, and you can do it also from command line to and do a type on it or something, right? So many ways you can see your source code. Since it's saved, then now I could just close RStudio and come back to it, and that code is available. So I'm going to just click on source. Notice when I click on source here, it just sourced the R data frame code from this directory, and then it ran it for me. That means that here, if I just Control C, copy this one, now I go ls here, and now and those variables are there. Data frame is there. All of that informations are there. So what if I just do something like this? If I just say RM, like last time we used remove, and this time I say a shorter version, and then ls, and now I just deleted it, and notice ls is not defined here, right? So if I say v1, it's going to say, I don't understand, there's no variable there. C1 is not there. So none of them are there, but if I just do that source, similar to clicking here, I could do it from the command line here from the console. I could just say source it. So this is how you source it, and now ls is all defined there. So whether you source it from this pane or you do it from the R console, then you can just run the code. Now, data frame is there, C1 is there, C2 is there, logical 1 is there, and V1 is there. All of them are there, right? So now the scope resolution that we did here, since dplyr is there, I don't need to do dplyr anymore in front of my functions. So the functions that are there within the data, and this one, if I say dplyr, the dplyr is actually the dplyr is the library name, right? So actually I need to do here just type in dplyr, and dplyr is the package name, sorry. Dplyr, I could do dplyr and then colon, and then all the functions are available for it. So if I want to get a list of functions that start with G, I type in G glimpse something, right? Glimpse. So then I say the data frame of this one, it will give me. But this time, because the package dplyr is loaded already, I don't need to put this scope resolution. I could just give the function name, glimpse. So similarly, if I say pull, and data frame is the output, and if I want to see v1, I could do that one. But notice this time I'm going to do the same glimpse without the scope resolution, because I know the function name glimpse is available since the dplyr is loaded already, as you can see here. Now it's going to, you don't need to type in the dplyr in front of it. But if it is not loaded, you have to do library to load it and then use this. So similarly, if I just say summarize this data frame, you can see it is not giving you much of this one because I have to do the summarize is a different function. So I'm going to show you that also. With a poll, you can see that it is polling this, and now if I say v1 and then v2, sorry, c1 and then c2. So notice every one of them that you do that exists, it will give you output. Logical one. However, if I want to just do poll with multiple columns, like C1 also with logical one, and then it gives me that information as well. Let's do also C2, comma, C2. And then notice, did you miss type it? So somehow C1, C2 is trace C error occurrence. So at this time, I'm checking to see why C2 is not there. Let me see L1. Can I get, yeah, L1 is already included V1. So notice that the poll statement is not doing it more than a few of them at the time. So I could say v1 comma l1, that would be working, but as soon as I do a c1, it's going to say the ranges or language last trace. That error message is not as meaningful, but it is somehow it misunderstood the number of columns that are pulled. So what you could do is if you say pull function, then you say, well, maybe I could use select the statement instead of pull. You could do what, sorry. Let me just, right here, okay. Let's just do df1 colon 4. See if it picks it up by number of index. Yeah, so notice that it says I must select exactly one column. So it does not pick it up by more than one, the poll. The poll is limited. In that case, you can do 2, you can do 3. Each one of them exactly, you can pull that information, but you cannot do like all of them at the same time. So a select statement would be better here. Select statement requires data frame, and then you could say 1 through 4. All columns show me the output. Or you could say 1 through 2, and the first and second one. Or 3 through 4. You could get everything, or you just say C1 and C2. You could get it by name also, or logical one, and then the order, whatever order you put here, you could pull that information. Remember, the data frame is this, but I changed the order the way I wanted to do it with the selected statement. And then sometimes with the selected statement, you can also do a where clause, right? So you can do where clause and then match more conditions in there. So you could say, for example, this, and then do a shift control M, and then that's a filter. You say where, let's say logical one is equal true. So let's say why did not come up with logical one is equal to true. I'm going to define it, redefine it differently. Control L. So I'm gonna say data frame here, and then say Control Shift M. That's Control Shift M. That's a filter. And now if I say select, I could pick up V1, comma V2, comma C2, C1. Those two you can pick up there, and then you could also filter some condition out of the selected statement to do that one. So let's do this df statement that we did here, and I'm going to say just 1 through 4, all of them, all of the columns. I want to just get the pull the data, right? Once you pull the data here, you're gonna just do 1 through 5. So we did that, the data frame select a statement. This is a piping. We're saying pipe it from this one and show me, select all the columns 1 through 4. V1 is the first one, and then L1 is the last one, 4. At this time, let's pull some more data. So we're gonna do the same statement here. We're gonna do Control Shift M here to do this pipe symbol. This is the filtering for piping. So at this time, I'm going to do this, and then say, now I'm going to a secondary prompt. Here's my first prompt, the greater sign, and then this one is the secondary. So at this time, I'm going to do filter function, filter, and I'm going to say V1 is greater than 5. So I don't want to include 5, but I want to get that data greater than 5, right? So notice that at this time I did V1 greater than 5. I could do further the same statement here. I did this, and then I did the filter greater than 5. I could also do something like this, and then filter 5, and then at the same time I'm doing Shift Control M, another filter, and I'm gonna say, let's say the L1 is equal to logical. L of the one that are logical is going to say, did you mean L1 is equal true? So I put the equality symbol. This is assignment statement. I meant to do the equality symbol. That is correct. So that's what I meant. And let me correct that one. That's a semantic error, and then it is caught at the runtime. So you're going to do that one, and then just change this logical is equal, and then I put this logical is equal true. Now we're going to get those ones true. And if you wanted the false, obviously you could do that false. And you don't have to do this statement. When you do this one first as 1 through this, you could just do on this one and say, give me all the filters that are logical there is true. Or vice versa, you say, give me everything that is true but logical is false. And then you will get the false statement. And then there's a lot of ways for data manipulation with filter function, with selected statement, and there's other kind of data structure that you can use. For example, if I just say iris here, you can see that the iris, the data set is available here, right? So then I can do iris and then say iris $. And then now notice these kind of variables that are available for me here. At the same time, I could say, give me the head of iris data set with $, species. Let's say I get that one, and then you could get all the information there. And if you say view that one, you could just get that information in a tabular form here, and then right here you could just see the data. Similarly, like if I say class, let me clear this screen. Clear screen is this. So I could say plot, let's say iris. If I want to plot the all iris data, I could do this one, and you could see here that it is done with this. And I could just assign a color scheme, color is equal, and then just use pound, and then let's make it 00 for red, and then sunny 5 for green, and then blue is 00, and then that's green color. So you just saw that this is a different size here, right? And if you want to just like make this coloring and then font a little bit darker, you can also do PCH is equal 19. And then with different line width and everything, you could do a line width is thicker and so on. So all of these things, if I just do line width, comma, comma, line width is equal, let's say 3. And then you could just run it, you can see the line width thickness is there. If I make it a little bit more darker, you can see like almost like a chip, even though it's iris and stuff, right? So that is this information. But this plotting, and there's a lot of different ways you can do these ones. But with iris data, when you do iris itself, you can pull all this information. Similarly, what data set is available. If you say data here, you could see all the data sets that are available on this and that you can use, like empty cars, women, carbon dioxide, cars, and then whatever, euro, and all that, Freeney, Faithful, and so on, iris data. So, and there's a lot of data sets that you can play with them. I just gave you a data frame that I wrote it myself at this time to just give you a demo, but you can work on all of these data set and then look at them at different views and pull certain information. So since I told you that, let me just move this one back here. Since I told you that those data sets are available, you can get head of iris data or tail of iris data. And notice that tail of the women data set, you can get all of that information. And then if you say, what is the women data set, you can just do question mark women, and it says the height and width of for American women. So you can get all that information and generate it, this one. Similarly for empty cars, say class of empty cars, what is that one? You can see it's a data frame, right? So if you just say empty cars, and then it's all the information about cars, right? And then notice that it has all the details here. But if I want to say, well, that's too much, normally on basic package, a string str is available for you under the utils, and then you can do str and then empty cars, and that will give you a lot of details, and also including the variables that are there. But notice it's a little bit messy. So if I say empty str for my data set called data frame, and then you can see that it is giving me the column there. But glimpse is like a little bit much more intuitive, that is going to help people understand it better. Look at how clean it is. And it says the column names, which are variables, the data type each column has, and the values for each of data type. Similarly, if I just give the glimpse of iris, you can see that the column name and everything that are there, and then the data types, and then the values for them. Similarly for women. So some of these packages that are there, you can say, for example, select the statement, select and say women, and now the package that we are looking at, women, height and width is there. So I could say height, and then just get the heights there. If I want height and width, then I just do width. And then I get both of them. And if I just want to get a view of them, you could get that one, and view, height, width, women. Oh, and because I just did not do any select statement. So view of this, and then select here, and then height, width. That's why that one. So now you have it in a tabular form in a view that you can go and alter this one. And then you could do even like height, width, or something. Then you can do filtration. Remember the filter that I showed you here? You can do something like this. Let's say you say select here. Since select is going to give you everything here, and then those information that are there, you could just say, well, if I want to just do a select and then Control Shift M, that's the filter, and then I could say uh, filter and then height is greater than let's say 60. And that's only pick up that record that are greater than 60. If you want only greater than 70, obviously, and that is a very easy way, you could do the same thing and just change it to 70, then only pick up certain information for you. So a lot of these things, data manipulation, are available with those functions, whether the select statement. I'm going to cover a lot more than just select and update another one. But for one video, I want to make sure that you understand when you're doing data manipulation with dplyr, if you just do a question mark dplyr package itself, this dplyr without E, sorry, dplyr package, you can see that there's a lot of functions available here. And then when you look at them, it's basically by doing data here. And you can see here all the list of the data sets that are there. And then at the same time, you can just get help on the list of the packages and that are available with dplyr itself. And there's a website here that you could also do this one. But the easy way to do it on that console is Control L here. You say dplyr and then colon. Now you have all the list of packages are there. And you on the R console, you can also press tab and it's there. Look at all the function commands that you can do with dplyr. This is basically data manipulation. You can do a start with, end with, and everything else, and a lot of that one. For example, when I say start with, I could say df is that. Let me just run the df command here. Control L. I source my code already, I believe, and then let me see what is the ls data packages that are there. df is there. So if I want to just let me see what I was planning to show you. I just lost my thought for a second. I'm going to pause it. So on this df, I want to just show you a little bit more with some getting some basic standard deviation, mean and max and minimum using some of the dplyr packages, how you do filtering. So if I just print the df like this is the entire data frame. But if I want to do data frame with data frame first and then say filter it, once you put Control Shift M on Windows, it will put the filter symbol for you here. So at this time, I'm going to do a select a statement. I want to pull field 1 through field 4. So this would give me the same data that was here, whether I do it this way or I just pipe it and do a select statement. And then maybe I could do the same thing here, another filter. So I put the filter symbol or piping symbol, and then I say now do a summarize. And notice the summarize method is available as a package name. At this time, I want to just do like a mean of it or standard deviation of V1, for example, mean of V1. So the vector one already has this list of 5 through 9, and then since I'm getting it, I get a mean one summarized value of 7. The mean between 7 to 9 is 7. And if I wanted same thing with the standard deviation, all I need to do is change the mean to ST. For standard deviation function, it will give me standard deviation. And then if I want to do a summarize for maximum value, which between 9 to 5 to 9 is 9 is the max, it will give me one row as a summary, and that's the value 9. And if I want to just say, give me the value of minimum, obviously it will give me the minimum. And if I just say, don't do the summary and do a summation of that V1, and whatever is the value of the summation, it is not understanding here. It says error in function V1. So let's see why it did not do a summation. If I just say sum of V1 here, it automatically does it here, right? Because the sum in this case, V1 was not understood, but just the basic mathematic formula, it will give me a product of it as well. If I say product of V1 comma V1, that would be growing bigger. So I can get the same one as many times I don't want to do the product there. Similarly for the sum, remember when you use a calculator, you're not just tied with only one variable or one value. So you could say sum of 2 comma V1. So this one is V1 is there. The sum was already 35, and with 2 is 37. And you could do it comma V1, comma V1, and then that would just go there. Or you just say V1 times V1, that also multiplier. And then V1 plus V1, and we'll do that one. V1 plus 10, obviously those values are interchangeably, it can be done element-wise operation. So if I do times 10, each number is multiplied by 10. And if I say V1 to the power of is this symbol, and 10 is going to grow exponentially to that one. At the same time, if I want to say V1 mod, which is this operator, and then you can just get that. So you learn a lot of stuff in this class, basically, in this video, in this session. I hope you enjoyed it. I'm going to stop here, and I want to thank you again for watching our channel. Please don't forget to subscribe to our YouTube channel, which is MyWebUniversity, my YouTube at MyWebUniversity. And this is the English channel that we have about, I have about 1,400 videos about computer science related topic, whether it's the entire course on Red Hat Enterprise Linux 9, which is about 4 hours, or Rocky Linux, or PDF on files, and then Solaris, Linux advanced levels, shell scripting, bash scripting, Xterm, Python, C, C++, PowerShell. There's a lot of videos here. You're welcome to enjoy it and subscribe. At the same time, let me move this Zoom out of the way so I can see the browser better. Let me just do that quickly here, which is not easy to move it around when it is blocking my view. Okay, yeah, now I moved it around. So if I just look at MyWebUniversity, my website, you have a lot of videos online for the English channel, as well as the 4C version that is here that you can just subscribe and watch. And then I teach it in 4C language also, which is Persian or Dari or 4C, one the same thing. So you just could watch these videos. And then if you go to the website, whether you go to the English or the 4C, you will go to the channel. Also, my book online that teaches about 14 different chapters, and that is Linux, automations and PowerShell, Python, C++, PDF files on multiple operating systems, thousands of PDF files, more than 32,000 PDF files over here, dynamically generated PDF. For example, if you're looking for R language, you could go to the dynamic chapter 12, you click in here, and then you just type in R here on the list. Let me move this one more time away. And then you just type in here R language, and then just get the output here, r.pdf, just getting generated, and you could start learning the PDF. But at the same time, since code reusability is part of my understanding of Python and of object-oriented programming, I did this on the Python that I generated manual pages on PDF format. You can come in on that reference section of this URL and then just change this one from bugs.or.project.org or-project.org, and you can get the documentation here, and you can just get the online documentation from our Pioneer itself. So you can see the manual pages and documentation. You can get all of that one in PDF formats and as well as HTML code and everything. And whichever one you like, you just read it, the whole section and by section. It's really nice. Okay. So that is about websites. And at the same time, if you're going to my website for learning, I would encourage you to go to my book online and just go through these chapters. And then for each of these chapters, I have videos online and advanced Linux stuff, and then in a tabular format. You could learn it by just clicking on it, practice it online, and the code that you click on, it runs on my cloud computers. Like, for example, process stream 3, it just gives you the system D, or a net process 1 is going to, and the system D process 1, it's going to give you the output here, process stream 3. Similarly, for all of the other ones, at the same time, for each command that you click on, you could get on the manual pages here, you could just get that one. And then if you just are looking for another command, like let's say printf statement, you could just get that one as well. So there's a lot to learn, and there's a lot of resources, there's a lot of videos for each of these rows, one video per row, 8 rows, 8 videos. There are more than that, and then you could learn it and enjoy it. God bless you all. Take care, have fun, and be nice to your community. Whatever you learn on, pass it on. Knowledge is power. By sharing, you care and you make everybody powerful. God bless you. Take care. Bye-bye.